Hey boys and girls, so today we're going to be going over lesson 5, which is recursive sequences. We'll get into what that represents in a minute, so let's start with the do now. Just like always, if at any time you feel like you want to pause the video, please feel free to do that, just as a reminder. Okay, so if I read the do now, it says Roger was just offered a position at his dream job, and he was offered the following salary plan. So I'm just going to highlight the word salary. I just don't know if everybody is aware of what that word means. It's just the money that you make each year. So I'm just going to write that up top. It's the money you make each year. All right. So if it's saying year one is $42,000, it means that in his first year of working, that's how much money he made in the entire year. All right. Then if I want to see how much money he made in year 2, it's the same thing, only now they're giving me some type of formula to follow. So in order to get his salary for year 2, I have to take year 1, what came before, and add 2 times 500. If I want to find year 3, I have to take year 2, which is the salary that came before, and add 3 times 500. And then if I want to find year 4, I have to take year 3, the one that came before, and add 4 times 500 to it. And then underneath it says, write the formula that would apply for Roger's 5th year of work. So if I wanted to find year 5, I'm just going to follow the formula up top. So I'm going to write year 5 represents, well, what does it represent? Well, I know that in order for me to find year 2, I had to use the year before, which is year 1. To find year 3, I had to use the year before, which is year 2, right? And then 4, I had to use the one that came before it, which was 3. So I'm going to do that here. In order for me to find year 5, I have to find year 4 first, because it's the one that came before. And then I don't know if you guys are seeing this, like the pattern. I'm multiplying with 2 for year 2. I'm multiplying with 3 for year 3 and 4 for year 4. So I'm going to now multiply with 5 for year 5. So I'm going to add 5 times. And then again, that 500 was used each time. So I'm just going to use it again, times 500. And then I'm good to go. If I find the formula for year 6, it's the same thing. So I'm going to write year 6. And then again, what came before 5? 4. What comes before 6? 5. So I'm going to start with year 5, because it's the number that came before. And then I'm going to add, well, it looks like I multiplied, by 2 for year 2. 3, 4, 5. So now I'm going to multiply by 6 for year 6. And then again, I'm going to multiply by 500 because it was the same all the way through. And then for the last part, it says, Roger's curious what he's going to earn 20 years from now. What do you need to know to find his 20th year salary? All right, so I'm going to start by underlining the question. What do you need to know for his 20th year salary? Well, I'm going to start off by just writing what that formula would have been in order for me to calculate that answer. So if I want to find year 20, I'm going to write that. And then just like we were using in the other equations, well, what comes before 20? 19. So I'd have to know year 19. And then in order to continue, I'd have to add, well, 6 went to 6, 5 went to 5, right? So I'm going to multiply by 20 because that's the number of the year. And then again, I'm going to include that 500 inside the parentheses because that's the number we've been using the whole time. So now I'm going to go back and just check. Well, 500 is a number they gave me. So I don't need to find that. I don't need to know that. They gave it to me. 20 isn't a number that I'd have to find. I know I'm looking for year 20 and these match. So I know I'm going to use 20. I don't have to find it. But that year 19, I don't know year 19. I can't just plug it in. I'd have to find that. So what do you need to know to find his salary in the 20th year? Well, I would need to know his 19-year salary. I would need to know his 19th year salary. Okay? All right. So lesson 5 is called recursive sequences. Recursive means what comes before. So if you look back at the do now, I don't know if you guys have caught on to that pattern that I was trying to show you. So if I wanted to find year 5, I had to use year 4 because it came before it. If I want to find year 6, I needed to know year 5 because again, what comes before 6? 5. If I want to find 20, I had to use 19 because what comes before 20? 19. So all of these were examples of recursive sequences. So let's look at this definition at the bottom. Certain sequences, not all, but certain sequences can be defined in a recursive form. So if I wanted to use a recursive formula, that's what we're going to go over today. It says each term is defined as a function of its previous term. That's going to be our first blank. Our previous term. Previous is what comes before. And then a recursive formula uses the first term. So our starting term is the first term, which is a sub 1. And then we'd have to use that with the nth term. But if I wanted to find 20, I had to use 19. If I wanted to find 6, I had to use 5. So if I want to find n, I have to use n minus 1, what came before, in order to do that. All right? So I know that this n minus 1 is going to be my previous term. All right? So just for practice, we're going to fill out this table together. So if I was given the 4th term, well, what comes right before that? 3. How am I getting that answer? Well, how do I get from 4 to 3? By subtracting 1, just like in this formula that they gave us a minute ago. So what comes before n? N minus 1. And again, how am I getting that? I'm just subtracting 1 to find the previous term, what comes before. So I'm going to do that on all of these. I'm going to subtract 1 to find my previous term. Well, 1 minus 1 is 0, right? So that just cancels. So all I have left is a sub n. What comes before n plus 4? Well, what's 4 minus 1? It turns into a 3. So it's going to be a sub n plus 3. What comes before 6? Well, 6 minus 1 is 5. So 5 comes before 6. Again, if I subtract 1 to find my previous term, what comes before n? N minus 1. And then again, what comes before n plus 1? Well, I know that 1 minus 1 is 0, and these are going to just cancel. So all I'm left with is f of n. All right. This is how you can mathematically find what that previous answer is going to be, but I'm going to actually show you a shortcut on the next page. All right, so if we all flip and we look at the top of the next page, let me just set myself up here. It says if I have a recursive formula, again, recursive means using the one before, it has two important parts. Okay, the first important part is actually that first term, a sub 1. So it's the first term or it's my starting term. And then the other important part is the previous term. And again, I know that my previous term is that n minus 1, what comes before. So the previous term is that n minus 1. All right. So now if I look at the first example, try to just watch me go over example 1 so you can see what I'm doing. And then if you want to try examples 2, 3, or 4 on your own, I mean, you could always do that after, but it might look a little confusing. Just stick with me. Okay. So if I want to consider the recursively defined sequence shown below, I'm going to start off by highlighting that recursively defined sequence. This is telling me right away that if I want to find any number in this sequence, I have to use my previous answer, what came before, because I'm seeing this keyword recursively. All right, so if it's a recursively defined sequence, I have to use my last answer to get the next. All right. If I want to use a recursively defined sequence, there's 2 important parts. The starting term. My starting term was a sub 1. It's my first term. And then we have to use our rule, which is using the previous term. And I know I'm using the previous term because I have that n minus 1 in the formula. So again, anytime you see n minus 1, it's the previous term. Okay. If I know that the first term is 15, the question says find the next 5 terms in the sequence. Okay. I'm going to start off by just writing out. If I know the first term is 15, and I want to find the next 5 terms, here's my first, second, third, fourth, fifth terms. Those are my next 5. So 15 was my first term. That means I have to now find the second, the third, the fourth, the fifth, and the sixth. All right, so I'm going to start off by just listing that here on the side. I want to find my second term, my third, my fourth, my fifth, and my sixth. Okay, and I'm going to do that by using this formula, which is a sub n, and then I'm going to use that n minus 1 plus 5. Just as a reminder, this is going to be my previous term. Okay, so I'm going to show you like the mathematical way to do it at first, and then I'm going to show you kind of a shortcut method, which might be a little bit easier for you guys to understand. Okay, so I know that this n minus 1 is going to be my previous term, what came before. All right, so what comes before 2? 1. I'm just going to do it again. What comes before 3? 2. What comes before 4? 3. All right, so it's the previous term. Not the second, I want the first. Not the third, but the second. Not the fourth, but the third. All right, what comes before? And then I'm going to take this number and I'm just going to add 5 to it. So I'm going to add 5, add 5, add 5. Okay. And now I'm just going to plug in and solve. So what was my first term? Well, the first term was 15. So I'm going to use 15 as my first term. And then I'm going to add 5 to it. And 15 plus 5 is 20. And I'm done. I know that my second term is 20. Now I'm going to keep going. How do I get my third term? Well, I have to use the second answer, my second term, and add 5 to it. Well, my second answer was 20. It's also right here. So I'm going to take my last answer, which is 20, and add 5. 20 plus 5 is 25. So I know my third term is 25. And then we'll do it one more time. So in order for me to get my fourth term, I'm going to take my last answer, which is the third term, 25, and I'm going to add 5 to it. 25 plus 5 is 30. So I know my fourth term is 30. Now, I know I said before I was going to show you a shortcut. You don't have to write out this step in the middle, okay? If it helps you, please write it out. But if this is very confusing, because I know for a learner like me, this might be too much going on and I can easily get confused. So I'm just going to show you the shortcut, which is, okay, I'm hoping you've noticed I'm just taking my last answer and adding 5. I'm taking my last answer and adding 5. So it's the same thing here. If I want to get my 5th term, I'm just taking my previous term, which is my last answer. So my last answer was 30, and I'm adding 5 to it. 30 plus 5 is 35, and I'm done. That was it. So my 5th term, my 5th answer was 35. And then last but not least, my 6th term is my last answer. My last answer was 35. So I'm going to just do 35 plus 5 and get 40. So I know my 6th term was 40, and that is it. All right. You're using your last answer, which is your last term, and added 5, because that's what this formula told me to do. And then again, I'm using my last answer, which is 35, and then adding 5 to it, because again, that's what this formula told me to do, and I got 40. So it was my last answer, like 30, and I added 5. It was my last answer, like 35, and I added 5. Okay, now if we look at example 2, I'm just going to use this blue shortcut method instead for the rest. So as I read the question, it says find the next 3 terms. So I'm going to underline that. Find the next 3 terms of the recursively defined sequence. So that's the key word that tells me I have to use my last answer to get the next. Okay, if I want to find the next 3 terms, well, the first term was 29, and I want to find the next 3. 1, 2, 3. So again, this was my first term. Here's my second. Here's my third. Here's my fourth. Okay, so again, I'm going to start off by just highlighting where my previous term is going to be. Okay. Anytime I see the n minus 1, I know that this is going to be my previous term, or it's my previous answer. Okay, I have to find the second term, the third, and the fourth. So I'm going to just list those on the side. The second term, the third term, and the fourth. And again, I'm going to find all these terms by using this formula. A sub n equals my previous term plus 10. I'm just going to highlight that one more time. It's that previous term plus 10. So I'm just going to even make little boxes here. My previous term plus 10. My previous term plus 10. My previous term plus 10. All right. So if I want to find the second term, I have to use my first term, which is 29. What's 29 plus 10? 39, and I'm done. It's that quick. So what was my second term? 39. In order for me to find my third term, I have to use my previous answer. What was my last answer? 39. 39 plus 10 is 49. So my third term is 49. And then again, to get my fourth term, I have to use my last answer, which is 49. 49 plus 10 is 59. So 59 was my fourth term. And then I'm done. All right. Skip on over with me to the next page for example 3. And then it's the same thing again. So I have to just read the question carefully. It says find the third term of the recursively defined sequence. So I'm going to underline the question. Find the third term of the recursively defined sequence. So again, I'm seeing recursively. That means I have to use my previous answer. I'm going to start by highlighting what that previous step is going to look like and then go from there. So if I want to find the third term, well, I know my first term was a half. So 1/2 was my first term. I want to find the second term and the third term to get my final answer. All right, I'm going to start off by just writing. I have to find the second term and the third term. All right. This formula doesn't have like 8 plus the previous, 8 minus the previous. There's nothing there. So that represents multiplication. So I know that I'm going to do 8 times my last answer. 8 times my last answer to solve. All right, let's jump on in. So if I want to find the second term, I have to use my last answer, which is the first term. It's a half. So I'm going to plug that in. What's half of 8? 4. So I know my second term is 4. How do I find the third term? By using my last answer, and my last answer was 4. 8 times 4 is 32. So I know my third term is 32. So if I reread the question, find the third term, I know that the third term is 32. And I'm done. All right, at this point, I suggest that you pause the video and you try 4 and 5 on your own first. And then you can rewatch it after just to make sure you're getting the correct answer. Totally up to you. I'm going to keep working, so do whatever you think is best. So it says find the fourth term. That's my question. I'm going to underline it. Of the recursively defined sequence. Again, recursively tells me that I'm using the previous answer to solve for what I need. I can see the n minus 1 is right here. So that's going to be my previous step, my previous term. And if I want to find the fourth term, that means I have to use the first term, which is -2, and then find the second, the third, to then get the fourth. Okay. So again, I have to find the second term, the third term, and the fourth term. And in order to do that, I have to follow this formula, which is 2 plus my last answer. Let me fill that in just as a refresher. Your previous term, or it's your previous answer. So it's 2 plus my last answer. 2 plus my last answer, 2 plus my last answer. I always do this just to set myself up so I don't get confused or mix anything up on accident. Okay, so it's 2 plus my last answer. Well, the last answer was -2, so I'm going to fill that in. 2 minus 2 is 0, so I know that the second term is 0. 2 plus my last answer, which was 0. 2 plus 0 is 2. So my third term is 2. And again, 2 plus my last answer was 2. 2 plus 2 is 4. So my fourth answer is 4. So find the fourth term. This one's different because if you look at example 3, it used A sub n. Here I'm using F of n. So I'm going to write it as F of 4. Not A sub 4, but F of 4 equals 4. Just so happens that my fourth term is the number 4. And then last but not least, number 5, it says state the next 3 terms. So I have to list all 3 terms in order to answer this question. And again, it's a recursively defined sequence. So again, that's a hint that I'm going to use my last answer to solve. So again, I'm going to look for that n minus 1. I see it right here. I don't see 1/2 plus 1/2 minus. I don't see any symbol, so I know that this is multiplication. So if I want to find the next 3 terms, I'm going to start out by listing what those would have been. So my first term is 100, and I want to find the next 3. So 1, 2, 3. So that's going to be A2, A3, and A4. So that's what I'm going to list out on the side here. I have to find not f of 1, but f of 2, f of 3, and f of 4 to answer this question. And again, it's 1/2 times my last answer. 1/2 times my last answer. That's the formula that I have to follow for this question. All right, so my last answer was 100. So I'm going to plug that in. 1/2 of 100 is 50. So I know that my second term is 50. So again, it's 1/2 of my last answer. My last answer was 50. 1/2 of 50 is 25. So I know that my third term is 25. And then last but not least, 1/2 of my last answer. My last answer was 25. 1/2 of 25 is 12.5. So again, 12.5 is my fourth term. So what are the next 3 terms? My next 3 terms are 50, 25, and 12.5.